Hi there. So I wanted to help you a little bit with Renaissance for Unit 4 and explain what this congruent triangle stuff is all about. So this whole unit is about congruent triangles, and triangles are congruent if they're exactly the same size and shape. And you have to base that all on the spelling of the triangle. So what we're going to look at here is this number 1 says that triangle EFG is congruent to triangle RST. So we're going to start with that. If you look at the first two letters of the first triangle EF in the spelling, we're going to take a highlighter and we're going to highlight the side of the triangle EF. Then if you look at the other one, the first two letters are RS. So we're going to find that side and highlight it the same color on the other triangle. So because of the spelling of this congruent statement, EF and RS are the same because they are congruent parts of congruent triangles. Then we're going to look at the next two letters. FG means that this side, F to G, get a different color, is congruent to or equal to these two letters ST. So we're going to match those up. And then the last side of a triangle in a congruent statement is made out of first and last letters. So EG, side EG on this triangle is going to be congruent or equal to side RT on this triangle. So then I think you're already familiar with the concept that in order to solve for x, we have to have an equation we can use. So we need to find two things that are equal so we can make an equation. If you look at my green side here, EF, you'll notice there's no information here about what the expression is that represents that side. So I can't really use it to make an equation with RS here. And if I look at the pink ones, GF has 3x plus 4, but on the other triangle, ST is blank. So I can't make an equation out of those two. But if you'll notice my orange ones, 4x plus 4 on this triangle and 6x on this triangle. So I have two matching parts of the congruent triangles that both have expressions. So I can say, because those are congruent parts, I can make an equation out of that. So 4x plus 4 is going to equal 6x because they're congruent parts of congruent triangles. Then I'm just going to solve this like I always would. Solve an equation. So I would get 2x equals 4. Then I'll divide. So I'm going to get x equals 2. Now, the thing to watch out for in Renaissance is you'll notice that there's this answer here of 2. That's not the answer because they didn't ask me to find x this time. They want me to find EF. So if I go back to EF, I actually have it circled here. It's blank. So I can't plug my x in there because there's no information. But if you look at the congruent parts, EF, the green line here, matches RS, the green line on the other triangle. So I can steal this and put it here. Since they're equal, then 7x plus 3 could work for either one. So if it wants me to find EF, I know that side EF equals 7x plus 3. And I know that x equals 2, so I can plug that in. So 7 times 2 plus 3, or 14 plus 3, which would equal 17. So side EF would be 17. So it's all about matching up the parts and finding out what you can say would be equal so you can make an equation. So let's look at another one. So let's see if you can continue using what we just did on the last example for this one. So we know side EF is going to match RS. So I'm going to find EF and I'm going to match it to RS. Sometimes starting with color helps get these ideas straight. And when you're working on Renaissance, you can screen snip the problem and you can use highlighters on your touch screen too. Let's see. Then FG, make sure you're highlighting the right one. FG would match ST, that's this one. So the triangles can be twisted and turned and it might not be the side you think it is. You have to make sure you're looking at the letters. And then EG, first last, would be this one. So obviously it's the side that's left, but you want to always look at the spelling so you practice that. RT would be this one that's left. Alright, so if I look at stuff that would match, I see that on mine, the only pair I have where I don't have a blank are my pink ones. So this should look kind of familiar from the last one. I'm going to have to make this equation again. 4x plus 4 equals 6x. So we already solved this a minute ago. So we know that x equals 2. And then we've got to look at what it wants us to answer. If it said what is x, we would have the answer. But it wants to know what is st. So I have to find st, and it's over here, but it's blank. If there was something here, I could just plug my 2 right into it, but there's not. So I have to go look at what st matches, and it matches gf, 3x plus 4. So I can put that in here, 3x plus 4. And then I can say, alright, st equals 3x plus 4, and I know what x is, so 3 times 2 plus 4, or 6 plus 4, so st equals 10 would be the answer to that one. Remember, you can always pause this so you have time to write and digest and or think ahead a little bit and then listen to see if you were right, rather than trying to copy as fast as you possibly can. Let's see what else we got here. Alright, number 3 now. Maybe you'll notice now we're talking about angles. Before we were looking at sides. So angles are even a little bit easier to match up because they just go letter by letter. Angle E, so I'm going to get that, and if it has an expression with it, I'll make sure I color that too, is going to match angle P because of the spelling. They're both the first letter. And then angle F, with its information, if it has any, is going to match angle Q. That one's blank. And then angle G is going to match angle R. So we've got G and we've got R has some information. Now, if you try to make an equation and find 2 parts that match like we've been doing, you're going to feel like, uh-oh, we're in trouble here. And we would be. Except when we're working with angles, there's something that can help us out. So this is important that you remember. When you're working with sides, you have to find 2 expressions that are congruent so you can make an equation, 2 sides that match. When you're working with angles, there is a rule that says the angles inside of, so angles, this is a symbol for angle, angles inside, this is inside a triangle add up to 180 degrees. So they have to all 3 be inside the same triangle, but then that would work. So if you look at this one on the left, we're just missing the one angle G, but we know from our color matching that it matches R. So I'm going to steal that 2x and I'll put it there. Then you'll notice I have a triangle that has 3 angles in it. Now this only works for angles, not for sides. But since I have 3 angles, I can say that they all 3 add up to 180. So if I started with the pink one and worked my way around, I would have 8x plus 2 plus 2x, that's the green one, plus 3x minus 4, that's the orange one, and those need to equal 180 degrees. So if I combine like terms, 8x plus 2x is 10x plus 3x is 13x. 2 minus 4 is going to give me negative 2 equals 180. Now you've got to be careful when you combine like terms, because if you make adding or subtracting mistakes, you're going to get stuff wrong, and then you're going to think you don't get the geometry when really it's just a little mistake with adding or something. So I'm going to add 2 to both sides, so I get 13x equals 182, and then I'm going to divide, and I'm going to get x equals 14. So, be careful. It didn't ask me find x, so once angle Q. So, angle Q is blank here, but it matches angle F, so I can take that information, 3x minus 4, and put it in there. So the measure of angle Q equals 3x minus 4, and I can plug my x in. So 3 times 14 minus 4, So that'd be 42 minus 4. So it's going to be 38 degrees. So the measure of angle Q is 38 degrees. So the difference with angles is that if you don't have two that match, like a pink one and a pink one that you can make an equation out of, you can always steal what you need from a matching part of another triangle and then find three angles inside one triangle that you can add to 180. But that does not work for sides. Just remember that. Alright, so here's one we can try here. Let's see. So we'll match them up. Angle A matches angle X because they're the first letter in the congruence statement. Now I'm going to go ahead and put some information in here. That means 90 degrees. Sometimes we want to label stuff as we know it so we don't think we're missing information. Alright, and then angle B is going to match angle Y, so B has some info, Y doesn't. And then C is going to match Z, so C's blank, but Z has some info. Alright, now my pinks, I have a blank one. My oranges, I have a blank one. And my green ones, if I write an equation that says 90 equals 90, that's just not going to be very helpful to me for finding out what X is. So I might have to use the three angles in the triangle rule. But they have to all be in the same triangle, so I'm going to need one here. So Y matches B, so I can use 4x plus 2 here because I can take it from B, put it there because they match. So now I can say that 4x plus 2 plus 90 plus 6x minus 12 equals 180 because they're all inside the same triangle. So then if I combine like terms, I would have 10x, 2 and 90 make 92, minus 12, let's see, 2 and 90 make 92, minus 12 would be 80, positive 80, equals 180, and then I'll minus that. This is all just your basic solving stuff that I expect you can already do. So I'm coming out with x equals 10. Is that what you got? So be careful. That's an answer here, but it didn't say find x. It might, but it didn't this time. It wants angle C. So angle C is right here, and it's blank, but it matches Z. So the measure of angle C equals 6x minus 12. So I can do 6 times 10 minus 12, and 60 minus 12 is going to give me 48 degrees for a measure of angle C. So it's all about matching, and if you don't have two angles that both have different information that you could make into an equation, you can add the three angles to equal 180 as long as they're in the same triangle. Alright. Now, you're going to have to keep an eye peeled for the ones that say isosceles. Okay, so in Renaissance, these are the ones that will trick you. So anything that says isosceles on your paper right now, make big notes about isosceles. You might already know this, but isosceles means that you have two congruent or equal sides. Okay, you have to know that automatically. And their opposite angles are automatically equal. And I'll show you what that causes. So, if it says you have an isosceles triangle, you know that two sides are the same, and it has base BC. So here's the base, BC. That means that these two sides are the ones that are the same. So the ones that aren't the base are the same. And if those are the same, then their angles that are opposite them, like this one and this one, are also the same. So when I start matching stuff and I say angle B, I'm going to automatically match it to C. Okay? Because angle B and C are the same. So angle B and C, and it doesn't always happen to be the first two letters in the statement. It just depends on where your base was and which two sides are equal. So angle B would normally oops, the congruent statement is actually over here. So angle B would normally match angle J. So I'll go ahead and color that in. And then because it was isosceles, B and C matched, and C matches K. So what we have on an isosceles triangle that's congruent to another triangle, we actually have 4 angles that are exactly the same. And so then D is going to match L just like that always did. Alright, so now it's going to be kind of like when we were matching sides, because I don't have 3 angles inside of a triangle that I can add up to 180. I could steal the one angle from the other triangle, but I'd still only have 2. So what I can do, just like with sides, you'll notice that I have an angle here and another one in the same color, a matching one, that has an expression. So since those two things are equal, like when we did sides, I can say that 7x plus 3 equals 9x minus 5. Then I'll solve this. So I've got 2x minus 5 equals 3. And then I'll get 2x equals 8. And then that means that x equals 4. And luckily that's not a choice, so I won't get sucked in. So now I've got to look at the question. The question wants the measure of angle C. Angle C is this one, okay? And it doesn't have any information, but it matches this one, angle B, and it also matches angle K. So I could use either one of those. I'm going to get the same number if I plug 4 in here or here. So I could say the measure of angle C equals 9x minus 5. And I would get 9 times 4, right? Plug in my x in. Minus 5. So 36 minus 5. Sorry, my computer is making some weird sounds in my ear there. Would equal 31. So 31 degrees. And if I plugged it in here, I would have had 28 plus 3, which would also be 31. So the isosceles ones, you have to think about finding the base and then making the other two sides the same and finding all the matching angles. So isosceles are a little bit tricky. Now, these are more likely to be the ones you do first in Renaissance. So these are all about the rules you first learned for matching triangles. You've got the side angle side theorem, you got the side 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 theorem, angle angle side, and angle side angle. And then for right triangles, if we have right triangles, which none of them on this page are, then the long one is the hypotenuse, the diagonal. You probably know that. That's the hypotenuse. And these guys are legs. So there's also a theorem that's called HL, but it will only work for right triangles, and we'll see those in a little bit. So let's start with this one over here on the right, because we're going to come to the big one last. So you're looking for which of these rules, since we don't have a right triangle, it won't be HL, will work to say that these two triangles are congruent. The first thing we want to do is add any information that's not already there, if there's anything we can add. So if these two triangles share the same side, so see how they both share this side, then that means that side's automatically the same on both triangles. So I'm going to mark that. And then they already had a couple other markings. So what I have here, I have to make sure that I'm looking at one triangle. So either this one, okay, or this one when I pick my rule. Because what will happen is that kids will sometimes look here, just write down this row here, and they'll say that it's angle, side, angle. But do you see that one of those angles is on the green triangle, one's on the pink? So that won't work. So you have to make sure that when you're naming your rule, it's all something that happened on the same triangle. So what we do have here is side an angle in between them, and another side. So side, angle, side. So that one would be side, angle, side. Alright, so then on this one down here on the bottom, if there's any information we can add, we want to do that first. So if you need to make a note to yourself, add any congruent marks that you can. And the only ones you could add is if they shared a side, or if you have, so I'm going to say marked shared side. So you know you can do that. Marked shared side. And here we have what are called vertical angles. So you're using a little bit of your Unit 3 stuff. So marked, not maked, marked vertical angles. And we can mark them. Now I can't actually use that one because that marker was already used, so I'd have to use a double. Alright, so now, again, we have to make sure we're looking at one triangle. So I'm just going to look at the one on the left. And what we have is, and this, you have to concentrate now. You can skip one side or angle, but not both. This will help you read it. So when you're reading your way around the triangle, let's say I started right here. So this would be angle. And if I start going this direction, do you see how I'm going to skip this side here and I'm going to skip this angle here before I get to the next thing? That's not legal, so I can't read that direction. So I'd have to read this direction, so I skip less stuff. So it's all about reading the direction that doesn't skip more than one angle or side. You can't skip an angle and a side. So if I read this way, I would have angle, and then another angle, and then a side. So this one would be angle, angle, side. Now, this one is a little tricky, and in Renaissance, this is one that trips people up. These little markers here, these mean parallel, okay? They're not congruent markers. So these mean parallel, not congruent. So they don't count as a side. But what they do tell us is that from Unit 3, so alternate, if we have two parallel lines cut by a transversal, alternate interior angles will be congruent. Alright, so that's going to be useful because if I have two parallel lines cut by a transversal, then I know that alternate interior angles, this one and this one, or you could have used this one and this one, it wouldn't have mattered, same thing, okay, are congruent. So I've got a pair of angles. Now, these two triangles also share a side, so I can mark a side. So now if we look at what we've got here, if I make sure I'm looking at one triangle, and remember that little arrow doesn't count, so you can start anywhere you want when you read it, but you, well, you have to start on, so you have three things in, oops, sorry about my mic there, three things involved, and you want to make sure you're either starting, not at the middle one, so you can either start here, you can't skip an angle and a side, so you'd have to read this way, so side, angle, angle, or I could read it this direction, which would be angle, angle, side. So it's this one, angle, angle, side, would also be called side, angle, angle. So this one would be angle, angle, side. You can, it's got two angles in it, but it doesn't have the included side because this side isn't congruent. So not the one in between the two angles, but the one to the side of them. So angle, angle, side. Alright, now these are all about match three markers, okay? There will be 4 sometimes or 5, but you only have to match 3 of them that spell a legal congruency rule. So the legal ones are angle, angle, side, angle, side, 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 angle, side, or you've got your HL if you've got a right triangle, which we do have here. So this might work for HL. So let's see. You can use everything you learned in Unit 3. You can translate, so you can slide them, you can reflect them, you can rotate them. So can you see that if I rotated this all the way around, that this angle, this would match up here, and this would match up here, but the single marker would end up down here, and so that's not going to match up. If I rotated this one all the way up there, then this angle would match, this side would match, and this angle would match. So that looks good. I have to make sure that it spells something legal. So that would be angle, side, angle, side, angle, and that does work. So it would be B. B would work because of angle, side, angle. This one you can see wouldn't work because the double marker is on the wrong side. It would need to be here, so that doesn't work. And the same thing here. The double marker would need to be on the diagonal side, so this one doesn't work. So if there's parts that don't match, they don't work. And if they do match and they spell the illegal rule, which is this one, then it also doesn't have enough information. So it has to be one of these allowable rules. Let's see. So for number 8, the triangle we're trying to match has 2 angles to choose from and 3 sides. So let's see. If I took choice A and I lined up this single angle right here, and so I'd have to rotate all the way around, then you see how this would need to be a triple, right, to match the other one, so that doesn't work. If I did this one, I would get this angle would match, this side would match, and the triple would be on the bottom, so this one would work. If I kind of reflected it, flipped it over and slid it up there, and this one would spell side, angle, side, so that's a good one, that's legal. This one would also match. See, this one has an angle, and this side would match, and this side would match. So this one matches, and it's going to trick people, but the reason that this one wouldn't work is this one would spell SSA or ASS, and that's not allowed. And then this one, if I got this double angle to match and this single angle to match, then this triple would be in the wrong place. So B is the only right answer for that one. Alright, so these are kind of fun. Those last two are all about matching triangles. These are all about solving little puzzles. So here's the rules you need to know. Anything that makes a line adds up to 180. A circle adds up to 360. And 3 inside, now they have to be inside, a triangle equal 180. So we're going to just kind of find the bits and pieces here. In order to find x, if I knew this little wedge, then I would have 3 things inside a triangle that I could use. So all the way around a circle is 360. So if I take 360 and I minus this 290 degree angle out here, then I'll know the little wedge. So 360 minus 290 is going to be 70. So that would be 70. And now I've got 3 angles in here. So I can do 70 plus 32 plus x equals 180. So let's see, that's 102 plus x equals 180. And then I could minus that. So x would equal 78. Now if they wanted me to find y, I would use the line rule because y and 32 form a straight line here. So I know that y plus 32 has to equal 180. So if I solve that, I would end up with y equals 148. So you use the line, oops, sorry about that, the line, the circle, and the triangle rule to help you solve the little pieces until you get what you need. Alright, on the last one here, let's see. If we had the 3 angles inside the triangle, we could just add them up and see what's missing to find out what x was from 180. But we need this angle here first. So I could use the line rule to figure out what that is. So if I do 180 minus 56, I'll get 124. So if this is 124, then I can just use the triangle rule to say that 124 and x and 35 have to add up to 180. So 124 plus 35 plus x have to equal 180. So this would be 159 plus x equals 180. So when I subtract 159 from both sides, then I end up with x equals 21. So I had to use a combination of the line rule and the triangle here to find out the missing part that I needed. So the same rules keep happening over and over, and I think let's see what you can do now with these notes and conquering your Renaissance. Be sure to ask for help if you need it, and use these notes to identify the kind of problem you're working on and see if you can remind yourself how that worked. You can do it.